First of all, I would like to thank the committee for inviting me for this presentation today. I have learned so much already in the first 2 days that I'm really, I would say, really proud to be part of this activity. And I thought by myself yesterday, if it is the last talk of the day, you should have a share. I ordered it, it didn't arrive because I didn't order it by Amazon. Okay. Nevertheless, ladies and gentlemen, let's talk a little bit about far UVC and the new standard UL8802. It has been mentioned already yesterday, and we have, and I wasn't aware of it, already a product that is certified by UL. My name is Laschefski, and I'm the product manager of UL, the lighting division in Europe. So I'm responsible for our product portfolio, and I share, I would say, with Ushio the same problem. We have too few projects in regards to this fantastic technology. Nevertheless, I would like to open immediately the question and answer session with one question, but I will formulate it by myself, and then I will answer it immediately. So, who the hell is UL? Very simple. UL, sometimes people know it, but usually they tell me, if I ask, okay, do you know UL? Yes, that's Underwriter Laboratories, and they issue the standard and then they do the testing. And this is unfortunately or fortunately wrong. So UL consists of 3 legal entities. Let me start in the upper left corner, that is Research Institute. We have a non-for-profit organization which deals really with, I would say, some problems that might occur in public. For example, burning batteries in aircrafts. And they will kindly ask to figure out what is the problem and how can we prevent it. And as soon as those guys are involved, very simple, the next stage might be a standard that deals with this problem. And the colleagues of Standards and Engagement, also a not-for-profit organization, so they work for fun, most likely, they will formulate finally a standard. And now what is important at this point, and that is different now to ICNIRP, as soon as you start to draft a standard that deals with the product safety, everybody can be somehow, I would say, participate in this drafting. So the chairman of the technical committee drafting this standard is not allowed to vote within this committee. He needs to take care for the topic of the constellation of this technical committee. So there is involved, for example, science. There is involved industry. There are customers involved, and so they try to involve all relevant stakeholders when a standard is drafted, and it should be definitely science-based, that's for sure. And then there is the red dot, and that is UL Solutions, and I'm part of the red dot. And we certify finally the products, but there is no need that this product needs to be certified against a UL standard. It could be an IEC standard. It doesn't matter for us, because if a customer shows up and says, okay, I would like to go with my products to Australia, we figure it out which standard needs to be applied, and then we test accordingly. So at this point, UL Solutions is part of the story, absolutely, but again, we test against all standards which are applicable for the product. Now I would like to discuss a little bit the content of the presentation. First of all, I will talk a little bit about hazard-based safety engineering. I will talk about the 4 different safeguard categories which needs to be taken into account if a standard is drafted. Then I will show you that even if there is no standard, or perhaps not the applicable standard, we have a process in place to cover the, I would say, uncertainties. Then I will show you very shortly only the development of UL 8802, and then I will come immediately to the topic of the photobiological standards which are referenced in UL 8802, and I'm really delighted by the fact that ICNIP is available at this point as an, I would say, point of reference, and I will show the difference to RP 27.1. And finally, I will give you a short overview about all the other UV standards which are gathering around and which could be, I would say, applicable depending a little bit on the situation. So finally, hazard-based safety standard engineering. What needs to be taken into account? There is the first topic, equipment itself, is a very easy topic, and it is leveraged very often because it provides a very high level of safety at this point. Simple, for example, if electricity is involved, you shouldn't be able to touch the wiring. Yeah? So this is something that should be taken into account in the first step. So everything that I would say keeps any kind of hazard away from the people using the equipment should be immediately incorporated in the product itself. So you should expect that within a standard you see all the requirements that leads to a safe product immediately by this category. Depending on the application, for example, if there is UV emitted and at a level which is above any threshold, then one thing is very much clear. If this limit is reached and if you need to have more UV, for example, then there need to be some personal protective equipment, like gloves, like shields, and so on. This is currently not part of UL 8802. Yeah, so there is no hint to such equipment needed in order to operate it safely. But this could be definitely a category, depending on the application, what might be required. You can protect the site itself. For example, if the site is lit by an UV light source, and it could be not only 222 nanometers, it could be 254 or whatever, then perhaps you need it for a disinfection purpose. Then you can add, for example, safeguards to your problem. Yeah? So if a door is opened and the radar detection equipment is combined with the light source, the UV part can be switched off so that finally even the site could be entered without any danger. This might be part of the story, and it is definitely considered in the 8802. And then we have finally behavior. That is always an aspect that could be taken into account. Don't expect it in 8802 because you don't see the light source, so how could you react personally? An example for behavior that might be, I would say, appropriate is, for example, if you stare at very bright light sources, you will usually look away. Yeah, so that is a kind of behavior that is expected. Or even if you think of the light bulbs which have been screwed into the lamp holder, usually no one touches inside these lamp holders. That is definitely possible, but by experience everybody keeps fingers away from it. That could be, I would say, another aspect that could be taken into account. So those four categories are usually, I would say, taken into account when a standard is drafted. Now the problem is with UVC, far UVC, at the moment when Corona hit the Earth, there was no, I would say, applicable standard in the world that deals with product safety for such equipment. So it was a new and innovative product, for example, to use far UVC light sources. And UN has a process in place to deal with such technology, even if the technology is not really standardized already. So there are two different opportunities we have. First of all, what we can do is we can develop here, that is in the middle of the slide, a so-called CRD. This is the certification requirement decision. This is always used when there is some freedom in the standard, which is, I would say, not expected. Yeah, so there is room for interpretation in the standard, and you realize, hey guys, there should be, I would say, a clear decision. And I remember the question I received from Professor Werner during ICFUST. He asked me, hey, will it be finally the skin or the eye limit that is, I would say, used for this UL 8802 standard? And we finally came up with a decision. It will be the conservative solution. And I will step into this a little bit later, but at this point, as soon as we figure out that within a standard, which is still and always a living and breathing document, if there is something not really clear, we can immediately issue such an CRD, which gives clearance and which provides additional information how to use this standard. And if the product is extremely new, and if there is nothing that really fits, we can issue a so-called outline of investigation. That is the first step to a standard. And then the process starts. There will be improvements, there will be discussions, more stakeholders will be involved, and finally, after the process has been finished, this outline of investigation will immediately turn into standard, and this is exactly what happened with 8802. Now, if you see 8802, where does it come from? Very simple. At the very beginning, we have already had, since, I don't know, nearly 100 years, the UL 1598. UL 1598 is an American standard that deals with the safety of luminaires. And everybody being involved during this COVID pandemic came along at the very beginning with a great idea, hey, we just need to have some amendments, we just put in an annex, and as you can see, that has been done in June and in August 2020. But then finally the committee agreed and said, okay, this is not enough. What we need to do is we need to really draft a new standard that deals and covers this topic. And they started the outline of investigation 8802. And after 5 editions, so after 5 revisions, finally the standard UL 8802 was published in November 16, 2023. And now you see there are 3 years in between. That is the fast pace. Yeah? If you think a little bit about what happens in the IC world, which is, I would say, everywhere outside North America, so everything but US and Canada. There are 53 members, when I remember correctly, or 56. This is more or less the basis for all the other international standards. They need finally to agree that the standard which is developed is the correct one. And I just can tell you, IEC did not even start this process. They are complaining that UL already is done, yeah, but they did not even start the process. It is discussed, and it is very much clear that sooner or later we will get, even in the IEC world, additional standards which covers this topic. And most likely they will look a little bit into the North American world, and perhaps they, I would say, adopt it. But generally speaking, again, the North American world is in drafting and starting such standards much faster than the IEC world. What is finally the I would say, content of the standard? Very simple. It consists of 5 parts. The first part is one that deals with UV germicidal equipment. This is everything that is uncontained from an UV radiation idea. and it deals with the application of occupied spaces. Yeah, so this is exactly what we are looking for with far UVC. We try to enable the opportunity to use this technology in an occupied space. Then there is a second part dealing with UV emitters assemblies, and those are the ones being used in germicidal systems, and the germicidal systems are the systems which are used on unoccupied spaces. So there you have an application where a huge, I would say, area, for example, in a hospital is using high dose UVC applications in order to disinfect, for example. And then we have an additional part 4 that is dealing with retrofit kits. And at the very end, in part 5, you find for occupied areas, again, UV radiation equipment. Then, and that is due to the fact that it is dealing with products, you will find additional annexes which gives you an idea how to test finally a motion detector, which requirements are needed if interlocks are used, so that in unoccupied spaces really nothing can happen, even if a door is opened and someone walks in. So you find all this information in regards to this, I would say, different applications in the UL 8802. And this is now the time to show you a little bit more in depth what is happening when it comes to the photobiological risk assessment. In lighting, photobiological risk assessment is, I would say, established since years. Yeah? So that is a common practice, and usually there is the use of the IEC 62471, which contains finally the ICNIP curves. That is, I would say, a methodology which enables us to risk finally the light source in different groups, and as long as it is group 0, there is no further requirement. We say it is a safe application. And then we have low, moderate, and high, and with those different groups you will find finally additional requirements what needs to be taken into consideration, how to handle it. As long as it is risk group 0, everything is fine, and please expect, very simple, as soon as the light source is, or your light equipment, or the far UVC equipment is categorized as risk group 0, you can use it in occupied spaces. Now, one thing is very much clear, and it is already discussed. There is from the ANSI IES a paper in place that is RP 27.1, and there you will find different values for the threshold or for the risk. Let's have a closer look at it. So first of all, the yellow curve is the ICNIP curve, and when I remember it correctly, the highest value, and so the highest danger, is at 270 nanometers. And then you will find, in addition to that, the so-called high curve. This is the green one, which matches the ICNIP curve at about 240 nanometers. And then there is a skin value, which matches finally at 250 nanometers, the 30% level. And here, at the right side, close to 300 nanometers, it matches again the ICNIP curve. So those are the values which are currently, I would say, in the discussion. After all the assessments that has been done in the TC committee in regards to UL 8802, there is a decision to use those values. And at 222 nanometers, I looked a little bit into the weighting functions. You can see that the ICNIP value is reduced to 15% for the eye, and it is just 5% for the skin. So you have, at this point, the factor of 20, more or less, in radiation when it comes to the skin. So there is definitely, I would say, a step forward from ANSI IES, and this is now part of the standard 8802. And that is really funny, because if you read the standard, you do not get an answer whether you should use the eye or the skin value. So there is no hint, and I immediately called my colleague who is representing UL in this technical committee, and I said, hey, what's going on at this point? And he said, hey, we already realized that there is, I would say, no such, decision, and we drafted immediately a CRD, this certification requirements decision, and this has been issued in March, at the end of March 2024, so it's 3 months old. So you can use this as long as the product is mounted at the ceiling and at a height of above 2.1 meters, and then you can use the skin curve. Otherwise, you need to have the high exposure limits to be taken into account. So that is finally, I would say, a living and breathing document. And if there is in the future more science that tells us it should be different, I promise you it will be changed. Yeah? One thing is very much clear. At this point, you have an opportunity, at least in the North American market, which is now at least somehow standardized. And I think that is really a very nice opportunity, and I'm glad that UL was so fast. So we have some additional standards in place. UL 9093, a very old standard like 8750. There is one that is applicable, I would say, now really for portable UV germicidal equipment, that is 8803. Which was not part of this presentation here, but if you would like to have more information in regards to this topic, you can definitely ask me. So finally, if you certify a product against UL 8802, you will get an UL mark, so this will show immediately that the product is a safe one. Whether it performs or not, there's a different story. And for the IEC region, that is important at this point. What we can do, due to the lack of standards, we can do an electrical, thermal, and mechanical assessment to the product. And we can draft immediately a so-called informative test report. And with this test report, you can work based on your own risk assessment, finally on a CE declaration that gives you market access to Europe. But within Europe, IGNIF curve is currently the one that is required by the EU regulation, so you cannot leverage the 27.1 in Europe. Yeah, that's, I would say, all for now, and I hope it was a little bit entertaining, but it was really quite tricky, I would say, at least from my perspective, due to the fact that I know 90% are, I would say, from biology and epidemiology, and it's for me a different and field of interest, but I think you might have get at least the idea that there is now something in the world that enables you a little bit more to get to market with your products. Please, the North American region.